All right. Good afternoon, everybody. It's 2 o'clock, so let's go ahead and begin. Welcome back. I hope you've had a great week. We're about to enter the weekend, so that's always exciting. So yeah, let's just recap where we left off last time and what we're going to be doing today. So this is obviously part two of the stream because last time I had to cut things a little bit short, but last time we had started to work on a real-time API for serving out our model. And if you can recall, if you watched the last live stream, I had a debug issue where I was trying to load the pickle file where we had saved our serialized model, and I wasn't sure why. And I had considered originally this idea of trying to debug it live on air, and I opted not to do that because I really had no idea what was going on. And I'm glad I didn't wait just because it took me forever to debug. So actually, I had to change quite a few things, or not quite a few things, but enough to our model that the model itself is different. So I'm going to walk through those changes here in a minute, and then we'll get back into our API talk. So let me go ahead and share my screen. While I'm pulling this up, one quick reminder: if you want to follow along with all my code, you can go to my GitHub profile, github.com/dkhundley. The project we're working on is called Titanic SageMaker BYOC. The last two parts of that probably don't make any sense to you because we haven't gotten to SageMaker yet, and we haven't gotten to BYOC, which stands for container, because we haven't gotten to containerization yet. But anyway, this is the repository that we are working out of, and so we have primarily to date been working out of Jupyter Notebooks here within. We've been working out of Jupyter Notebooks here within Jupyter Notebooks. Yeah, that makes sense. Okay, sorry. All right, so let's go ahead and walk through the changes that I made. So one of them is a smaller one. So this one has to do with the gender column. Originally, I had just done like a very simple label coding where I actually did like an if equals males, then give it a 0. If equals females, then give it a 1. I opted instead to include or turn this to a one-hot encoder, and the only reason I did that is because I wanted it to be able to handle unknowns properly. And so let's say you passed it a value that was neither male nor female. What it's going to do is it's going to give its own value or it basically just gives out zeros, because that's what this handle unknown here is doing, is it's giving zeros where it doesn't know what to do. So this one was a smaller change. So this, and speaking of this change here, so you might recall that I struggled to remember like what this handle unknown is doing. Apparently I was not using it right. And apparently, I mean, there are different ways that you can use this, but I found that actually using this handle unknown equals ignore seems to have worked best for us. So that's the only thing I did to the gender column. So moving on, embarked, I didn't really touch aside from fixing that handle unknown issue. And then, so age, this is where things started to get a little bit interesting again. So you might recall that I was deciding to fill null values with the median age, and I was using something called the simple imputer for that. And that worked just fine whenever I was doing, or like we were doing like the full training and everything. And, but the issue is that it didn't work well for single values, or single records, I should say. And the reason that is because if you wanted to use simple imputer, you had to do a reshape of your matrix. And for some reason, the reshape of the matrix is different if you have multiple records versus a single record. So when you're writing your code to actually do this, there's no way to really like check for that. Well, I guess there is now that I think about it. But anyway, I just found that it was easier to, since it's only like the simple imputer is really better if you like have multiple like features that you want to like get an imputed value for. And since we just had the one feature and like it was just age and it was a median, I just did a straight median lookup, and then we just set it like the null value to fill in with that. So the median here is at 28. And then the other things here were the same. So that's it with feature engineering. Now, as far as the predictive modeling goes with our scikit-learn pipeline that we created, that's where things also started to get weird again, and this is where I kind of banged my head against the wall for a bit. Okay, so you might recall, let me scroll down here into creating our full pipeline. Okay, so I was using, here, let's go ahead and let's highlight this data preprocessor piece. So you might recall that I had a couple of different function transformers in here that were taking these helper functions from above and basically using those to do a column transform on the different respective features. And so specifically we were doing that for age, the age, sex, and embarked features. I don't know why this is. but I could not get the the function transformer working properly for this age bitting function. So specifically, whenever I tried to do like an inference later that was supposed to create dummies for the age bins, for some reason the column transformer mixed in with the pipeline just would not return all the dummies, and I have no idea what that was. So my way of getting around that was this is where you can kind of see something is new. I created this might be easier if I come down here to the pipeline itself. So you can see at this pipeline, we have three steps now. We originally just had the two. It was originally just feature engineering and predictive modeling. But now I added an age binner in the beginning. And so what this is doing is it's actually this function transformer here. And what I did is I just separated out this idea of, we're going to do the filling the nulls with the median age of 28. And then the only thing we are doing here is we are doing that PD cut that made the ages into these respective things here. But you'll notice there is no one-hot encoding in part of it. So at the end of this step, we go into the next step, and that's where this data preprocessor picks up to do all the one-hot encoding. So at the point when it is picked up, the age column has already been transformed to be those values like adult, young adult, child, things like that. And then other than that, that's really it. So then the pipeline basically stayed the same, and then I retrained the model. So that's it. That's it for the changes. So things are working now. It took a ton of debugging to figure out. And like I said, I still don't know why the one thing is not working right. And I spent way too long trying to figure that out. But okay, so like I said, these notebooks have been pushed up to my GitHub if you want to pull that code down for yourself. And that I have already retrained the models and then uploaded the pickle files as well, also to GitHub. So if you want to follow along with today's project, although I don't think it's super well. Yeah, if you want to follow along in real time, you will need that pickle file. And so if you don't have the time to or want the desire to like go back and change all your notebooks, you can just use my pickle files that I have pushed up in GitHub. Okay, so let's come back into our API talk. And so I just want to give a quick conceptual overview of what that was before we jump back into the actual code itself. So as I explained it last time, I kind of like to think of an API as like a storefront. A storefront in this idea of where, if I am a customer and I walk into something like a cell phone store, the merchandise usually isn't out front in a cell phone store. It's usually in the back room. And so I'll walk up with the specifications of the phone that I want. Usually, for me, it's an iPhone. I want I'm not going to get it, but, so we had the Apple keynote the other day, but I would get the 13 Pro Max. I'm okay with the base storage, although if I had unlimited money, I'd go for the terabyte storage. Blue, probably, maybe gray. But anyway, I'm handing the specifications over to the clerk, and then the clerk is taking my information and then goes into the back room, at which point I really don't know what they're doing. They could be doing anything. Most presumably, there's a stock of shelves in the back with the phone that I need. And but theoretically, what they could be doing is they could be having carrier pigeons flying in and out with these phones attached to them, and it doesn't matter to me what it's doing as long as at the end of the day I'm getting my iPhone. So that's what an API is nice for, is that it can give information to users like myself without exposing the back ends of their system. So even though I am interacting with this API to get this information, I am trying to get the information back in a way that's secure. I apologize, I'm monitoring the chat here again. You are welcome to answer questions. Somebody had just noted that I have a big gulp. It's actually a Polar Pop. So yes, it's Coke Zero today. So Coke Zero is the drink of the day. Thank you for your comment there. That's actually my wife's. All right, so back into our API. Let me go ahead and share my screen again. Okay. So I actually went ahead and deleted pretty much everything from this API folder here, or file here, just to show you from scratch how to do this. So the one thing I did change, that was another thing I forgot to mention that I did change from the predictive modeling, is for some reason, whenever I was just using the standard pickle library to save out my pickle file, it didn't like to do that. And then likewise, so there's another library called joblib that's been very popular. But the problem with joblib is that at least me and my coworkers have noticed that it does, like the serialized files from those models don't work well with versions of Python 8 or higher, and that's not good, obviously. So, I'm trusting the joblib eventually will get updated or something to correct for the issues. But I did find the workaround for that is using this thing called Cloud Pickle, and the functionality is basically the exact same. So as a pickle or a joblib. So that's why in here we're using Cloud Pickle, but don't think about it too much because it's basically serving the same functionality that we were doing before. Okay, so like I said, we are going to go ahead and create the API from scratch again, and that's because it's really quick, and I think I've done it enough times. I want to see if I can do this from total memory without any mess ups at all. So let's see if I can do this. So first thing we need to do, of course, is instantiating the fast API object. So this is just instantiating fast API for us. I'm going to call it API equals fast API, nothing in the parens. And then I need to load the model. So loading the Titanic model from pickle or serialized pickle file. Okay, so what we need to do here is with open, and then go into the directory path. So it's up one over into models, and then I got to remember what I named it. So let me look here. RFC pipeline.pickle. That doesn't count. That doesn't count as far as not memorizing something. That is, I'm trying to see if I remember the syntax, and so far I think I'm on board. So with open pickle and then this will be a read binary RB as, and then just as F, and then within the colon there. So we're going to do the RFC pipeline equals cloud pickle.load F. Okay, so now this is basically loading up our model as this RFC pipeline. And so you might recall then, with the storefront idea with an API that there's different endpoints, and the endpoints are basically different functionalities in which somebody can interact with an API. So usually there's four main interactions with an endpoint. There is the post, the get, the delete, and the update. So a post is posting out information and then expecting to get something back. So in my our storefront case, that means the information that I'm posting to the clerk is the specifications of the iPhone that I want, and then they would basically be returning the iPhone to me. Similarly, with our model serving APIs, we are passing in the data that we want inference on and getting an inference back. So that would be like a post request. A get request is more of just I just want information without even necessarily passing anything up. So in this case, think about maybe if I had been a couple weeks earlier to the store and I'd already pre-ordered an iPhone and I just wanted to check the status, then I might just do a get to fetch whatever the status is without passing any new information in. And then delete, is similar to post, where you're posting up what you want something deleted from behind the scenes, and then updates similar as well. But the only two we're going to focus on for today is post and get. And the reason for that is because we want a post endpoint for our prediction. You might recall this. And then we want to get endpoint for health. All right. So, and then also you can name your endpoints whatever you want, but I will say that later on in this series, we'll be talking about how to deploy this model out onto AWS SageMaker. And AWS SageMaker requires that you use a very specific nomenclature. So we are going to go ahead and begin with that nomenclature. That way we don't have to come back and change it later. All right, so I like to very thoroughly comment my code, as you can see, so I'm just going to make two quick comments. I'm actually going to do the health endpoint first. So first, I'm going to just have like a little shell here that says defining the predict endpoint here. Okay, and then I'm going to make a couple spaces and then defining the health endpoint. Okay, so to do, so you may recall that we had to do functions before, where functions are these things in programming, not just within Python, but pretty much every programming language has a function, where a function is basically you take in some information. It's kind of like an API in a sense, except you actually can generally see what the logic of. Sorry about that. I got a call. I don't know if you saw there. And it's basically taking in information and then transforming it somehow and then returning it back to a person. But like with a function, generally you can see like the guts of the function, which isn't good if like I'm the customer. Like if I'm a customer and I walk into AT&T or Verizon, I don't I don't think they really want me to know per se, like what's going on behind the scenes, or maybe they don't care. But like at least in the information security field, like you don't want people like getting into your backend databases, obviously. So I don't even remember what I was talking about with that. Oh yeah, Python functions. So Python functions can also have these things called decorators that sit on top of them, and decorators are basically like extra added functionality that help assist the function in some capacity. And so in this case, the decorator is a fast API decorator that allows us to like define the endpoint and what it does. Okay, so the decorator for the health endpoint is going to be API. So remember again, our fast API object is called API, as we denoted here on line 12. So it'll be api.get, and then within quotes here, we need to define our endpoint name. So we're going to call this ping because this is what SageMaker requires. And then underneath here, we're going to define our function for actually defining this health endpoint. So I'm going to call it async.def health, and it does not need to be fancy at all, just because the only thing this is designed for is just so these APIs are unless you have some sort of thing that stops them, like at night or something, they're constantly running around the clock. So you always want to make sure that they're up and running just fine. And usually a lot of APIs, you'll get like thousands, if not hundreds of thousands, if not millions of requests a day. And so obviously you want to make sure that it's working just fine. And so that's what this ping endpoint is doing, is behind the scenes, SageMaker is pinging this endpoint a couple times a minute, or maybe like a couple seconds, just to make sure that the health is of the endpoint is still okay. Okay, and I meant to say health, not Heath. Duh. Okay, all right, so the only thing we're going to do here is return a JSON response. JSON response of, my gosh. I'm just going to do a little Python dictionary status, colon, healthy. Okay, so that is the ping endpoint. So let's go ahead and define the predict endpoint again. So predict endpoint, we again our API, but then instead of get is going to be a post. And we are going to call this invocations. So usually I like to use the endpoint name of predict because I think that makes more sense, but SageMaker says otherwise, so we will go with what SageMaker says. So we need again to do an async def. I'm going to call the function name itself predict, and then so as opposed to health where we're not passing anything, we are actually going to pass in something this time. Oh man, this might be the one thing that I can't remember how to do. Request is request. So this is basically saying like we want to input the request as the request object from Fast API here. And so let's go ahead and define out the rest of our endpoint here. So getting the JSON from the body of the request. Okay, so this is going to be an important piece that we didn't really cover as much last time, and that is JSON. So JSON stands for JavaScript Object Notation. It looks very similar to the syntax of a Python dictionary. So actually this down here is a Python dictionary. So you can see that it usually has like key value pairs. And so like the key here is status and the value is healthy. So when JSON is used across the internet or across the whole programming spectrum for a lot of different things. But in the internet especially, like this is how we pass information back and forth in the form of JSON. So what this is actually doing is we are going to be sending over our data that we want for inference in the form of JSON, and I'll show you here later on in the stream of how to generate that JSON, and then we will transform it properly and then send a prediction out back to our user in the proper manner. Okay, so getting the body from the JSON from the body of the information. So I'm going to call this input data equals await request.json, and then we need to transform this into a Pandas data frame, transforming the input JSON input data. I'm going to call this input JSON just to make it make sense. Input JSON into a Pandas data frame. Okay, so that's going to be, I'm going to call this input df because now it's going to be a data frame equals pd.dataframe and I'm going to call this, and this is where this might get a little bit weird because I think you have to put it in brackets like this in order for it to get to like transform properly. Input JSON, and so this is now going to be a data frame, and now we can actually pass this data frame in to get inferences from the model itself. So in transforming the input from, did I not spell something right? Okay, well, yeah, there we go, missing the S there. All right, so getting the prediction from the Titanic model. Okay, so we're going to call this pred because pred is short for prediction. Pred equals, okay, I actually am going to make an intentional mistake here, and I'll show you why, and we can come back here in a minute to fix this later. All right, so pred equals RFC pipeline dot predict, and then we are putting in the input df. Okay. All right, so there's our prediction, and now we're basically ready to return this back to the user. Returning the prediction back to the caller. So we refer to people that want something from our API as the caller, so they're calling the API. So that's why I'm saying we are returning the prediction back to the caller. So we are going to say return. Oh, I forgot. I put the JSON response. I didn't put the keyword return down here. Okay, there we go. Return JSON response. So same idea here. And then we are going to say, another little Python dictionary that just says prediction. And then we are going to say pred. Okay, so, and I feel like I'm missing a step in here, but I can't remember what it is. Okay, but I guess we'll see here in a minute. Okay, so in order to actually test to see if this works out, well, actually, we can go ahead and test out the health endpoint. So as you might recall, we use, in order to start the actual API up, we use something called Uvicorn, and I'm not going to explain again. I'm not going to explain what Uvicorn is. It's a, what is it called? I can't remember what the A stands for. Something. Oh my gosh, I can't remember what any of the letters stand for because I'm thinking of WSGI as well, because this is an ASCII and there's a WSGI. Something gateway interface. But anyway, I don't remember what it means exactly, but you do need it in order to serve this out as like a production endpoint. So you might recall that I created a little shell script that helps us to do that. So we installed Uvicorn here, and so we are going to serve Uvicorn out on host 0.0.0.0, port 8080, and we are noting in here that we wanted to look at the so API. So what this is referring to, the first API is referring to the first API.python file. So this is the same guy that we were working in before, and then the second API in here node is pointing back into this actual API object. So, and like let's say I were to change this to my API, and I'm going to change this back. Then what I would need to do this here is I'd need to go my API, and then so vice versa, I can change the name of the Python file itself. But for our sake, I'm just going to keep it API, and then I'm going to change this back. All right, so let's see. We should be able to at least load up the API and then test out the health endpoint. So we are already down here. I have opened up my terminal down here, and I'm actually going to split it in half. So I'm going to do a split right so I can have two terminals basically. Okay, so what I'm going to do on this left terminal is I'm going to go ahead and start up the API. So remember, I created this bash script to help it be a little bit easy, and that way I'm not typing out these commands every single time. So here I'm just going to do a bash start api.sh. And so, by the way, within this container directory, you might notice that I added a couple little extra files. This train.py file actually really doesn't have much in it right now. We're going to come back into a different live stream and talk about what this is doing. It's basically kind of a spoiler alert. This is going to help us with like containerization of our model, but we're not ready to talk about Docker containers, and we're definitely not going to get to those today. Okay, so back to our API. So we are going to start this up, and it should start up just fine. Okay, all right. So far so good. So if I just wanted to do a request against that health endpoint, what we do is we use this default command that's in pretty much every Linux or Linux-based operating system called curl. Again, I can't remember what curl stands for, but basically we're going to say, all right, so curl localhost, because 0.0.0 is our localhost 8080, and then we want to invoke the ping endpoint because that's just our health endpoint. And there we go. So we get a response back over here that says status of healthy. Hoping my picture's not in the way of there. No, we're fine. And you can see over here on the left within the actual script of our running API that we hit the ping endpoint. So this is where I was talking about with SageMaker. Like if you actually go and look at the logs of SageMaker, you'll see that it just hits the ping endpoint like every 5 seconds. So like the logs will be filled up all the way with like a ping endpoint. So that is ping, and so this is good to go. So let's go ahead and shut down our API off on the left here with a Control C command, and that'll shut things down. So you can see it is now shut down, and now we are ready to test out the invocation endpoint. Well, almost. So as you recalled, might recall, we do need to generate some test JSON in order to be able to do this. So I started to create a new notebook here that is just called generating test data, and I'll show you. So this is something that I don't do, again, daily off the top of my head, so it might be something I have to Google one or two things, but let's go ahead and do that. So I do know, let's go ahead and importing the necessary importing the necessary Python libraries. Okay, so I do know we need import JSON, and so JSON is a standard Python library. It's not one of those that you have to pip install like some of our others. And then I'm also, of course, going to import Pandas as PD. Okay. So importing the necessary Python libraries, and then importing Pandas as PD. And so then what we basically want to do is we want to take one of the records off of the CSVs that we've been working with. So what I'm going to do is, you might recall that whenever we downloaded the Titanic dataset from Kaggle, it came with, well, it actually came with 3 different files, but we only kept 2. It was the train.csv. Of course, we've been working with that pretty consistently throughout. And then it came with this other test.csv. So we're actually going to load up the test.csv one and then extract some JSON data off of that. Okay, so I'm going to say, so loading the test, the Titanic test data from CSV file. Okay, so I'm going to call this df test because it is the testing, what do you call it? The testing data is a pd.read CSV, so it is up1 data, and I actually this was a minor refactor that I did. I did refactor the data directory to organize the data better, so it's actually now under this raw folder, so I'm calling it test.csv. All right, so viewing the first few rows, viewing the first few rows of the test data. Okay, so I'm going to call this df test.head. I always like to do df test and df. I'm sorry, not df test. I always love to do a head or an info, like whenever I first load up a data frame, just because that gives you the most quickest impression about the data that you're working with. So you can see that I got our test data here. Note that our test data does not have the survived column, and that is intentional because we do not want to be able to, or it's not designed to. It's supposed to be test data that we're trying to get an inference on, not stuff that we already know, basically. And that's why, again, whenever we wanted to do our validation in our last session, like we split the training data set itself into a training and validation set. And that's because we needed that ground truth survive column to actually be able to perform like the correct kind of validation metrics that we wanted to do. Okay, so now that we have done this, we basically just want one of these records off the top, and it does not matter. I'm just going to take the top one. So I'm going to call it, I'm going to say extracting one record, or the first record from the test data. And so the way we do that, and this is where I'm going to have, I don't know if I'm going to remember this off the top of my head correctly, so I'm going to call this first record, not one record, first record equals df test, and then I think we can just do df test again, .iloc. So iloc stands for index location 0. So index location 0 is off to the left right here. You can see that is this row here. So if I did this right, and I'll go ahead and do first record, and this should print it out just fine. I hope I did it right. I always do something wrong here with this. None of are in column. So I always can never remember like what the precise syntax for getting this is. So let me just try a couple things. So df test, this is where you get to see like some of the things that I do in real time. Df test iloc 0. That didn't, well, so this appeared to have worked, but I actually want it to be in data frame form, and this is not in data frame form. It's just showing us the information about this. I'm wondering if I can just do a df test. This might be a cheater way to do it. So df test head, and so dot head. So you might recall that dot head by default gives us 5 rows. You can just set it to be, you could set it to be how many you want. So I'm just going to say 1, and that actually worked. Okay, so that. I guess, if it works and it's simple, let's go ahead and do it. So there is our one record, and now we are basically ready to export this as JSON. And this is where I don't remember how to do this off the top of my head. So let's see. I'm just going to do a quick test here. So I think first record.json, or I think Pandas data frames have this attribute called toJSON that will transform it to JSON. But I think you need to remember like what precise rows it is and stuff. Or I'm sorry, what precise parameters. Sorry. Thinking, talking, and trying to debug things all at the same time, not my strong suit, so apologies for that. All right, so to JSON, I'm going to leave it as empty, and I'm not going to set it to on any other variable right now. I just want to see what the output of this does. Okay, so that actually appears to be, well, no, this isn't correct because you can see that it's doing some weird thing where it does the passenger ID. Because I think you actually have to send some parameter called orient equals records or something. Okay, and so actually this is correct. And so basically we want this information here saved out to a file that we can make use of later. So what I'm going to do here is, I hope I'm doing this right, because I think it's JSON .dump. All right, so JSON .dump first record to JSON orient records. What missing dumps? How about dumps? Nope. Okay. Well, all right. I'm gonna have to look this up probably. All right. So say, well, I want to check what is the object type of this thing here. So first record. All right. So type. So it is no, it's not a string type, is it? No. Okay. Well, let me check to see. I'm going to Google over here, so I'm going to call this Google. All right. Taking a sip. All right. Save Pandas record as JSON. All right. So if I come into here, so it says to JSON here. I wonder if there's any extra fields that will help us to know where to save it properly. Or let's just say, well, is this not a JSON? Like I'm just so confused of like this would not be a JSON. So I'm going to call this. Let's just go ahead and say trans. I'm going to make a comment here. Transforming the first record from Pandas data frame to JSON, and I'm going to call this first record JSON equals this. Okay, boom. Uh-oh, there we go. Sorry about that. All right, so then I want to do a type first record JSON. First record JSON. Okay, it's still saying it's a string value. That's very curious. All right, so first record JSON. Okay, so can I do a JSON.dump? JSON.dump. Well, so I got to look up what does JSON.dump do again. So JSON dump, or Python JSON dump, I should say. Python JSON dumps. Okay, so encoder and decoder, So dumps, dumps, pretty printing, deciding JSON. So this is some fun stuff that you get to see me do. So if you have any questions along the way, again, I have my chat down here. I'm constantly looking at it every like 30 seconds or so. So I'm very happy to answer any questions if you have anything. Okay, JSON, maybe I have to do a JSON.load first. So, all right, so JSON.load, first record JSON, I didn't think that was going to work. Okay. I wonder if there's a different way to. All right, so to JSON, and then I want to save it to. So pandas to JSON. Save data frame as JSON. Okay. So how to export? So sometimes the documentation itself can be very confusing. So I always do advise that you try to use the documentation first. But if you're really confused by it, and honestly, like I was or am, sometimes it's just easier to read like a something else that somebody else wrote. So df.toJSON. So they are saying, you may use the template to export the pandas data frame to JSON. For example, the path where we'll be storing the JSON here. So to JSON. All right. So what was okay? So pandas to JSON. All right. We'll get into this again. Okay. So it looks like it does offer a path. Let's see if this is going to work. All right. So coming back into our notebook here. So it looks like I should actually just be able to do a straight shot there. So saving. First record to JSON. All right, and it looks like I should just be able to, I'm going to cut this cell out. I am going to delete this first part here because we should not need that. So it looks like the first parameter in here was actually path. So path equals ... Here, let me go ahead and put a comma there. And actually, so you don't have to do this, but I like to clean up my parameters by making sure they're all on the same line. I don't do that all the time. It just depends, on what I'm working on. But I'm going to do that here just because. All right. So test / test JSON. All right. Let's see if this works. To JSON got known argument path. Well, it's called path or buff. Oh, okay. My bad. All right. So let's go back to here. Path or buff. All right, so if that worked right, then we should be able to see our JSON somewhere. All right, let me go ahead. Let me go ahead and see if we can find that. So remind me later. Repos CD. We're going to go into our Titanic, and it should be in our CD tests. Okay, and then open. So again, reminder that this open command will open this in the terminal. And sometimes I just like to use this to see if this did actually export the way I wanted it to. All right, so let's go into text edit. And it looks fine. It's not exactly the way I would like it formatted, but this is going to work for us, I think. So let's go ahead and see if we can make use of this. So in order to make use of this data to hit our invocations endpoint here, I'm going to create another little shell script that's basically doing another curl command. Let's see if I can remember how to do this off the top of my head. So I'm going to call this local predict .sh. And so what we need to do is we're going to do a curl command, and it's going to be request is going to be a post request. Data is going to be at, and I don't know why it needs that. JSON data needs an @ sign, so it's going to be at test json.json. Content type is going, or I think you actually capitalize those. Content type is application/JSON, because that is this. Some of the stuff that you're seeing here is just typical like curl request kind of stuff. So don't worry about it learning or like trying to learn it too closely if you don't want to necessarily. And then the endpoint of course is going to be localhost 8080, except this time instead of ping is going to be invocation. So I hope this is right. Like I said, I purposefully did screw something up, so I actually know it won't work, and I'll tell you why I purposely did not do this correctly. All right, so let's go and show you this. So again, to start up our container, we are going to initiate the bash command to start the API. Should start up just fine because we've already started it before and we didn't make any alterations to it. All right, so now we are ready to do our curl request against the invocations endpoint. So I need to CD over to where the JSON file is that I created. Did I write that right? Test.json.json. Let's see. Test.json. Okay, that's right. All right, so let's go ahead and do a bash local predict. So it will screw up. So over off here on the right, this right terminal is going to say internal server error. And this is why I like to have these things side by side, because internal server error doesn't really mean much to us, but you will see off on the left the logs of what might have happened to screw things up. So when I hit this, uh-oh, so I must not have done... Oh, okay, so I did something wrong in here. And I wonder if I even need this. I use this all the time, but I've wondered if I even need this. So let's see if we can get by without it. All right, so let's try this again. All right, so there we go. Internal server error. You can see that there's some sort of weird issue going on where you cannot find the age key. Oh my gosh, why is this? Oh no, I am really hoping I didn't screw something up. Okay, so I actually did, before I deleted everything out, because I actually did have this working before, I did save it to my GitHub. So let's go ahead and reference GitHub to see what I screwed up. I know I screwed up multiple things. Well, the one thing that I did screw up, but we haven't gotten to that screw up yet. Okay, so going into container, api.py. All right, so I did, so this is all fine. It looks like input df. I wonder if it's just that. So the way I like to debug these things, so I need to shut down the container here. So actually, within our start API script here, what we can do is we can add another little flag in here called reload. And what this reload flag does is basically anytime you make new changes to your underlying Python script, it will restart the API with that new configuration added. So that way I'm not having to shut down the API and restart it every single time I want to make it like a minor change to the API itself. So I think that's right. So let's do a bash start API.sh. So it is using the reload process. Okay, so I haven't made any changes yet to this. I am curious. I just want to do a print of the JSON just to make sure that the print is working okay. So, or that the stuff is working okay. So notice when I hit Command S there to save this script that it did a reload here off on the left. And so my face might be in the way here, so let me move my face on up. Oops, sorry about that. All right, so let's go ahead and do a bash again with the local predict to see what happens this time. Same error, but this time we should be able to scroll up in the logs and see like what's going on to see if we're even getting the JSON out appropriately. So it looks like we are. And this is where sometimes this, like these brackets, I don't know if like they really like matter or what. So let's go ahead and change that and see what happens. So I changed that, and let's see if we get to my other error. Okay, yes, we did. So that must have been our error. So again, it's kind of weird where, so let me just show you the test JSON here again. You'll notice that, you know, the test, for some reason, the Pandas like 2 CSV will export this JSON with these like square brackets on the end. You don't necessarily need these, so I could delete these out. But the problem is like if I delete these out, then it might like actually break the underlying code here. So you might recall that I had to take the little brackets out here. And I'm going to go ahead and take this out since I know what the issue is. Yeah, so the only thing to be cautious about there is to make sure that it's consistent with whatever your clients are calling with. If your clients are constantly calling with JSON that looks exactly like this, then make sure that you're accounting for these square brackets appropriately. If not, then make sure that you have it flipped around backwards. Okay, so the thing that I messed up here is that this RFC pipeline here has kind of a weird output because you can kind of see object of type ND array is not JSON serializable. So that's what this basically is here, and I can follow up the trace stack here to see what's going on. So you can see that it's failing on the return of the JSON response. It's failing that we can't return this pred for some reason, and I'll show you why. So if I just print out the print and just so we don't have a ton of bad info coming at us, I'm just going to put that in quotes. So off on the left here, so this should have restarted again a couple times. Off on the left or the right here, if I do a bash again, we'll actually get something that looks fine. And then off on the right here, you can see that in this bracket, you can see 0 within this bracket, and that's because that is our actual prediction score, but is being exported by this predict function as this little array, this little Python array. And so the only thing we have to do, it's actually pretty easy to resolve. So we have to do two things. We actually have to get the value out of the array. So the first value in an array, or the first value in most things with computer programming is actually 0 and not 1. So off on the right here, I need to do a 0. And then the other thing is this actual 0 inside this is actually a value, a data type of type numpy.array. So actually, I'm going to have this restart again a couple times just to show you what I'm talking about here. So let me go ahead and hit Command S to go ahead and save this. And I'm going to go ahead and try invoking this again. So you can see, oh, sorry, I meant to update this back to what it was as well. So returning the pred. Okay, so bash local predict. So you can see the object of type int64 is not JSON serializable, but it's not just int64. I actually had to do some special debugging. It's numpy.int64. It doesn't like that. If I were to change it to a standard Python int object, then it works just fine. And since this is an integer that's going to be a 1 or a 0 all the time, because the predictive value is did they survive or not. In fact, let's go ahead and call this one survival prediction. Survival prediction. And we are going to say, so the way to change, like cast this from like the int numpy version of an int to like a regular Python version of an int is simple. It's just wrapping this with this int right here. So let's go ahead and save this, and now we should be good to go. All right, so let's go ahead and I'm going to do a clear over here just to clear out all the messiness. So I'm going to do another bash local predict, and this time finally we get our proper prediction. So survival prediction of 0, and you can see off on the left we get a post of the invocations with a 200 code of OK. So our API is working and it's all good to go now, finally. I'm trying to, so we are at 2:45. Again, I'm watching this thing down here to make sure to see if you have any questions. This is really it though as far as the body of the API goes. And so this is actually not too complicated. In fact, you saw me code all of this in real time in less than 45 minutes, and I actually did not hardly make any mistakes. It was just the one bracket thing, and then I mentioned before that I did purposefully mess up this one part, so I'm not going to count that against myself. But I'm kind of happy with myself that I did this all right. So one quick note: there are a couple different Python libraries that you can use for API frameworks. Fast API is what we are using here. Another very popular one is called Flask. So sorry, I was just trying to move my picture down and I accidentally moved my screen down. I was using Flask for a long time. The reason there are a couple of reasons I switched to Fast API, and one of the big reasons, and actually let me go ahead and show you this. So let's go ahead, to start up my terminal. Oh, it looks like the API is already running. So the Fast API actually has its own built-in documentation generator kind of thing with what they call something called Swagger UI. And so by default, there is an endpoint that is already created whenever you start up any Fast API endpoint called /docs. And so let's go ahead and look at that within our browser here. And so the way we can do that is just go into localhost 8080, oh my gosh, if I can type, 8080/docs, and you can see here that we have our 2 endpoints. And so this is super, super nice. And you can even like look inside the endpoints, and you can even do like test against things. And so you can see that like, there's nothing that's necessarily defined as like required parameters. So this is actually a very simple API. This is the other really nice thing about Fast API in particular is that you can put kind of like data validators on your incoming data. So like if you'll notice that there's no parameters here, but if I were to define these data validators, then I can make sure that any data that is coming into the API is of an expected value type. And so you can't just pass anything to the API and it will return the proper response back to the caller. So I'm not going to cover that here. But I actually did write a full blog post on Tor Data Science about this, and it is in my other one of my repos, and that is this DS Quick Tips. If you go into Dockerizing Fast API, and then you actually look inside the container here, so this is going to look pretty familiar to you. Excuse me. So this is actually working with the Iris dataset instead of the Titanic dataset, which is another toy dataset that people like to use. And so you can see that this basic predict is basically doing what we already did, was just use the standard request object. But what you can do instead is so this is like the fancier version of it. So this is actually taking an Iris object, and so we define this up here. And this is basically saying like, okay, we want just these 4 features of these 4 names, and they must be of a float type. And so that even this is more simple than what you can do with this. So you can actually set defined values of like, we only want values between 5 and 10. Or 10 and 20. And then the nice thing is, coming back to this Swagger UI here, is if we did define that, then the parameters would show up in here. And so it's just like what you can do. And then you can even add some other additional things that like make this a lot fancier than it is today. So this is just very basic. It's just showing the 2 endpoints and that they're of a type post and a type get. But it's nice. Flask did not offer this before. The one thing I'll just note is, just like cell phone competitors, Android versus Apple, I'm sure that Flask will eventually come up with something similar to this. But for now, I'm really happy with Fast API. It's on Toward Data Science, which is a data science publication on Medium. You'll notice a lot of the posts out there are starting to use Fast API over using Flask. And then other people like to use Django as well. I actually don't know anything about Django because I haven't had any need to use it. But Flask is very, very similar to Fast API. In fact, let me see. Because whenever I first started working, I pretty much exclusively used Flask. So you can even see here. Let me go ahead and pull this up. So this is the syntax for Flask. So you can see instantiating the Flask application, and then ignore this part. But this here is basically almost the exact same syntax as like creating an endpoint for Fast API. It's just a little bit different. So instead of doing the app.post, you're doing the application.route, and then this, and then but you still have it's basically a Python decorator as it was before. Okay, so I'm trying to think if there's anything that I want to cover today, because we've already covered quite a bit. I'm tempted to cover unit testing just because we have some time. So in case you're not familiar with what unit testing is, so unit testing is basically this idea that we want to make sure that our code is always working in an expected way. And so what we do is we write tests to ensure that what we want to do is like expected behavior from our stuff. So this is where I might have to reference some of my other documentation. Actually, one of my last blog posts I wrote was like all these different unit tests, or all these different tests that you can create for a model serving API. So I definitely advise you go check that out. But let's go ahead and do some basic unit testing. So I'm going to come back. Well, let me go ahead and share my screen again. Take a sip. Okay, so coming back into here, within our test folder, I'm going to create a new directory called unit testing, or I'm going to just call it unit test. And then under unit test, I'm going to call this, I'm going to create a new Python file called testapi.py. Okay, and this is again one of those things where I remember what we need to do. I just cannot remember the precise syntax for doing that. So I'm actually going to have to look at my personal GitHub. But just to let you know that I do, just to demonstrate that I do conceptually know what we're talking about here. So what we're going to do is we need to instantiate, like there's this offered functionality within Fast API that if you wanted to basically start up your Fast API for a test client case, you can do that as part of the special object. We also need to load in our test JSON, as that's going to be fed into our endpoints in order to be able to get the proper information that we want to get. And then we're going to be creating what we call assert statements to help for that validation check. So what the assert statements are going to be basically saying is, okay, the output of the health endpoint or ping endpoint, it needs to say status healthy, and if it does not, then throw an error or assert an error. Okay, so this is, again, I'm going to have to go back and look because I never remember this off the top of my head. And not a big deal. Most data scientists, machine learning engineers, software developers in general don't remember syntax of everything off the top of their head. Okay, so if I come in here, so this is another post I wrote, so unit testing, test API. Okay, so this is where I was talking about. I need to get the test client, and then I'm going to be importing the API. If I recall correctly, there was something weird about this, but yeah, so let's go ahead and do this. So we need to import JSON. Let me make this bigger for y'all. Pinch to zoom. All right, so we need to import JSON, and then I need to come back in here. So from API.testClient, from fast API.test, hold client import, I think it's just called test client. And then we actually need to import the API itself. So from container, here, and you will know that was fine. From container.api, so this is our container directory, and then with the API file import, we want to import the API itself. Okay, so I zoomed in just a hair too much. I'm going to steal the headers off of these because I don't like having to do this dash line business every time by hand. So I'm just going to copy this header over. I'm going to change the name of it. I'm going to call it test client instantiation. Test client instantiation. So I think it is client equals test client and then API. Let's see if I did that right. Hot dog, there you go. So, all right, I need to put a comment on here. Instantiating the test or fast API test client. Okay, so this client we're going to be using throughout the remainder of our unit testing in order to perform that proper unit testing. And so we need to do that, and then we also need to load in the JSON. Loading in the JSON from test file. Okay. Let me call this loading in the test data from JSON file. That makes more sense. Okay. All right. So what is that? I'm going to have to look at this one. Okay. So we're doing, okay. So with open, so it's going to be one level up. And that's just going to be test JSON.json. And I think it was just R because it's not a binary, is it? So let me check again. I do have it as a read binary. Okay, read binary as F, and then it's going to be test JSON equals JSON dot loads, or is it load? And you know, this is the most confusing part about JSON. There is a difference between load and loads, and I can't remember what the difference is. So that's why I'm glad I looked. So it is just load. So I'm going to load in F. Okay, and then all right. So like I said, I like to put 3 spaces in between like my major groupings of things. So you got our import. I didn't even say up here importing the necessary. Put an extra E in there. Necessary Python libraries. Okay. And All right, so I'm going to create a new heading down here called. I'm going to call this test. Unit test creation. Unit test creation. So this is where we then create a number of different like test cases for what we want to do. So I'm only going to create 2 test cases. I'm going to create one for the prediction endpoint and then one for the health endpoint. So I need to come back in here because I can't remember if there's any special decorators or anything. Okay, so I'm going to put I'm creating a unit test for the invocations predict endpoint, and I'm actually going to start off with the health endpoint. So creating a unit test for the ping or health endpoint. Okay, and then I'm going to split this off on the right here in our I'm going to minimize that down a little bit. I'm going to split this off to the right. Split right. That way I can remember exactly what we called this over here without me having to change anything. Okay. Oops. Got 2 of the same guy open there. All right. So def. So we're basically going to create this as a Python function. Def test ping. And then I can't remember, do I have to put anything in here? Do I need to give it the client? Apparently I do not need to give it the client. Okay, so I'm going to do the test ping, and so we are going to hit the client dot get. We're going to do the get endpoint at ping, and then so we need to do the response. So the response equals client dot get is ping. Is that correct? Yes, that is correct. All right, so 2 things that we want to see from this. We are going to assert response.status code. So the status codes across the internet, whenever you do certain things, it's consistent across the board. So 200 is always this was successful. 404 is probably the most popular, is not found. And then usually the 400s are like the error codes. 200 are usually some sort of success code. And I can't remember what 300s are. And then I think 500s are like internal server errors. So those are consistent across the internet. If you want to learn more about those, I would just go to like Google like curl error codes. But anyway, so we want the response status code to be 200, and we want assert response, and it's the body of the response, and I can't remember if it's response just response.body. No, it's response.json. So response.json equals okay. So what do we call it over there? We called it status healthy. So it's got to be this precise syntax. If I forget anything in here, we will have something go wrong. Okay, so that is our first unit test created. In fact, so let's go ahead and test this out. And so in order to test this out, I'm going to create another little shell script here. So I am going to create a new file called, what do I want to call this? So I'm gonna come and organize this a little bit differently here. So I'm gonna create a new directory called curl scripts. Curl scripts. So I'm actually gonna move this local predict one into curl scripts here, and then I'm gonna call. Well, I need to come back in here to see what I did. So let me come back. All right. So I want to make sure. Well, I don't want to get out of there yet, so I'm going to just open this in a new tab. I'm starting to get a lot of new tabs open. So let's see if I can close out a couple. That way we're not cluttering ourselves too much. Okay, so, I'm looking at the exact same thing. Duh. Okay, so let's go back up to tests. So you can see that here we have a number of different tests. So this is the run security, or running the unit test. So here we are doing the PyTest unit testing. Okay, so we're using PyTest to help ourselves do our unit testing. And so what this is basically doing here is it is taking the output of the unit test and saving it into a log file. And the only reason I created this here is because a lot of companies are going to want something called like an evidence of test or multiple evidence of test. And so this is like, we could do the unit test without logging out these things. But if you wanted something to hand to an auditor or something, this is some nice functionality that it's going to allow us to do. So I'm actually just going to, kind of cheat this here and just copy and paste this guy in. So PyTest, or I'm going to create a new shell script. And I'm going to create a new directory in here called test scripts. And then under test scripts, I'm going to create did I already create a new script? No, I didn't. Okay, so I'm going to create a new file called run unit test. Run unit test.sh. So then again, this is basically emulate similar to how we have the Start API or even the curl scripts. These are commands that you can run without doing the shell script kind of thing. It's just easier. So I'm going to do, since this is going to be one down from where I want, I'm going to first do a cd ... and then I'm going to paste all this in. So log file, and I need to create I'm going to call this test reports. So this is going to export our thing into the test reports. And so it's actually called unit test, not unit testing in our directory here. So let me create a new directory in here called test reports, test reports. Okay. Okay, so we should be able to go ahead and run this. And so we don't, I can't remember if you need to have this open or not. So let's go ahead and try it without it. So under cd test here, let me move my pretty face out of the way for you all. Not actually that pretty. Sorry, I need to take another sip. All right, so what we should be able to do, we should be able to go into our test scripts, not test scripts, test scripts, okay, and then we're going to do the bash command to, bash command to run the unit test, and hopefully we should have, no module call container. Okay, so this is something that I did run into, so let's come back into our, I was worried we might run into this. Let me go ahead and minimize this for now. So this is called a Python relative import. So we are actually importing this from our local directory. And so Python relative imports are really weird to kind of get working. And I honestly don't want to go into like too much description of like why it is weird. And I'm just going to kind of skip to like how I fixed it. So, and I fixed it in here. So let me go ahead and see if I can find it. I'm not going to talk about what this init py is doing, but this init py I think was important to actually getting this working. So we have unit testing in here. Is part of this? No. Maybe I just need the init py file. So sometimes, you know, these things, the relative imports can be solved pretty simply by just adding these init py files. I thought I had to add something else in here, but I can't remember now. Let me check one more thing. In the container, do I have something in here? Okay, so I'm just going to add init.py files in a couple different places. I actually find that it's easier to do since they're empty, it's actually easier to do within the command line than actually do it in the user interface. So I'm going to just do a touch init .py. So I need one there. So cd into test. So I'm going to do again touch init.py there. Cd into unit tests, and then do another one of those touch init.py there. Okay, and let's see if this will work for us now. And it looks like it's doing something this time. Okay, so it looks like something did happen. Okay, so it could not find the test.json, but that's because that's actually my bad, because I changed the relative path of where this was at. So let's go ahead and update that. So let's go ahead and run this again, and hopefully this should work just fine this time. Okay, so what is telling me? Warning summary. That we are no, it's not going to be using this collections before. Okay, so the way that unit tests work is that like, don't ask again, that it'll show warnings. So warnings are things that, you know, things that you need to be mindful of, but not things that are necessarily going to break your code. But if, you know, if you see some red business going on, then like you probably like want to make sure that like that it's actually not working. So let's say, for example, I forgot the exclamation point here. Let's go ahead and do that, and I'll show you what happens here. All right, so let's go ahead and run this our unit test again, and you should see this screen at us here. So you can see here, one failed, big red failure, and it'll tell you which one failed. Failed, unit test py, assertion error. It's a status healthy equals status healthy, and that is does not. So equals is like a comparison operator that says it's supposed to, like these two are supposed to match. And the reason it failed is because it obviously doesn't. So let's go ahead and add this back in here. And, you know, just for fun, we should be able to go into our test reports here now and be able to look at this unit test report.txt where there is nothing in here. Why is there nothing in here? This part is not super important. I'll debug that. I mean, it's not super important because we can at least still see the test results just fine in our script, but it is important if you want to create some sort of evidence to test that you can be able to hand to any auditors or anything like that. All right, so let's go ahead and create our other unit test to create the test predict. And in fact, I'm going to call this test ping endpoint test invocations endpoint. Okay, so this is where I don't know if I'm going to remember the precise syntax again. So I know it's going to be another response again. So this time it's going to be response equals client.post. And so the post is going to be /invocations. And I'm trying to remember, is it data equals test JSON? Let's see. Let's see if I remember that right. Okay, so coming back into here, so JSON equals test JSON. Okay, close. All right, and then we're going to do a couple of assert statements again here. So assert, I like to just do an assert of the response code, status code equals 200, and then assert response.json equals. So if you recall correctly, the predicted value here is 0, so it should be what do we call this? This is why I have it up on the right. So survival prediction is 0. Did I do that right? Okay, so let's check to make sure that this is okay. Okay, so I'm going to run my unit test again over here. And if I didn't do, okay, so survival prediction assert. Okay, so I did something wrong. And let's see what I did wrong here. Response.json. Okay, so apparently in here I didn't I neglected to get that. So, okay, is there a way to print out that response.json? Let's print it out just to see what it's going to do. Print response.json. So this is probably not the best practice for like debugging things, but it's just, you know, an easy way to that I find that you could do things. Okay, so let's see. Does it show in here? So print. Okay, so left equals, so prediction. Did I spell something wrong? Survival, survival. Okay, I spelled something wrong, and I spelled something wrong over here. Okay, interesting. All right, so, and I should have seen that. So survival. Okay, so all right. So maybe I didn't screw anything up in the unit test itself. It's just that I screwed some things up in the actual API itself. Again, this is why we write unit tests, is because we want to make sure that these things are good to go. So all right, let's go ahead and run a unit test again. So we had the same warning, but both of them passed this time. All right, so that is our unit test written. So let's go ahead and commit all these changes. So I'm going to commit all these changes to GitHub, and so if you'd like to see all these, they will be up in my personal GitHub. So I'm going to call this updating API and writing unit tests. So there are more different kinds of tests that we can do. I'm not going to cover those as part of this series. Like I said, I just wrote a blog post on all the things that you can do, and so within the same Git repo or that we've been coming through, you can see that there's actually a ton of different things that I did. So under test, you can see that we have a container scan, dependency scan, linter, performance, status scan, and then of course the unit test. Okay, what do I want to cover to else today? I think that's it. We've been going for about an hour and 15 minutes. Our unit tests are done. Our API is done. So I think this is a good stopping point, because we will come back next time and start to wrap this all in a Docker container. And a Docker container is really important. I'm not going to explain what that is right now, but it is really important not only for deploying things out on the SageMaker, but for deploying things out on the Kubernetes and then other things. Docker containers are not just used for machine learning. They're used in a wide variety of purposes. They've become quite the popular technology in the last couple of years. So yeah, we will cover all of that in the next stream, but I think we're going to go ahead and wrap up for today. So I hope you all enjoyed this stream. I hope you all learned something. I apologize again that, you know, you had to watch me through debugging some of that. At least you didn't have to watch me through debugging like the computer and stuff, because that was kind of a nightmare. But yeah, so this was fun. The API stuff is done. I hope that all makes sense. Like I said, we will come back next time. We will start to Dockerize everything. And then I think so, like I said, Docker we'll cover in the next stream. And then maybe in 2 streams, we'll start to delve into SageMaker and how to actually get this whole API out on the SageMaker. Or maybe we'll just cover SageMaker in general. Yeah, I think we'll just cover SageMaker in general as like a SageMaker 101 kind of thing. So let's do that in 2 streams. But next stream is Docker containers. All right. Thank you, everybody. If you have stayed this far to the end, you are all great. Thank you very much for watching. I hope you all have a great weekend, and I will catch you in the next live stream. Thank you all. Have a good weekend.